Okay, looking at your semester exam review, first we got f of x minus g of x. So we're going to take f of x, which is x minus 6, and subtract g of x, which is negative 2x plus 5. We need to make sure we subtract the entire function of g of x, so we're going to distribute that negative. So of x minus 6 plus 2x minus 5. Combine like terms, we get 3x, negative 6 and negative 5 are negative 11. F of x times g of x, we've got x minus 6 times negative 2x plus 5. We need to distribute twice here, so we're going to do x times negative 2x, which is negative 2x squared, x times 5, negative 6 times negative 2x will be positive 12x, negative 6 times positive 5 will be minus 30. Combine like terms, we get negative 2x squared plus 17x minus 30. F of x into h of x, we're going to put f of x inside h of x. So we're going to take this f of x, plug it into all the x's of h of x. So we'll have negative 2, instead of x we have x minus 6 squared plus 17 times x minus 6 minus 30. We need to FOIL this out, so negative 2, x minus 6 times x minus 6 plus 17. We'll distribute this in a second. When we distribute this out, we get negative 2, x squared minus 6x minus another 6x, so minus 12x plus 36 plus 17x minus 102 minus 30. Still going to distribute my negative 2 now, so negative 2x squared plus 24x minus, let's see, 72 plus 17x minus 132. Finally, combining like terms, we get negative 2x squared. Let's see, 24 and 17 make 41x minus 204 would be your final answer there. Putting h of x into g of x. We put h of x into g of x, so we're going to put this into here. So negative 2 times negative 2x squared plus 17x minus 30 plus 5. Don't forget the plus 5 there at the end. Distribute. We get positive 4x squared minus 34x plus 60 plus 5. So 4x squared minus 34x plus 65 would be your final answer. 5 and 6 are inverses. On inverses, we're going to switch x and y. So instead of g of x being y equals negative 2x plus 5, we're going to change it and make it x equals negative 2y plus 5. And now we want to solve for y. So we'll subtract 5, x minus 5 equals negative 2y. So y equals, we're going to divide all that by negative 2. So we get x over 2, which is going to be negative because we got x divided by negative 2. And we have negative 5 divided by negative 2. So it'll be plus 5 over 2 equals y, which is just our inverse function. So e equals g inverse of x. Same thing with f of x. It starts off as y equals x minus 6. So we're going to switch it to x equals y minus 6. We just switched the x and y. Now we solve for y. So x plus 6 equals y, which is just our f inverse. The domain of g of x equals the square root of x minus 9. You can either remember that we can't take the square root of a negative number, or if you forget, you can look at the graph. When you look at the graph, it starts here at positive 9 and continues to the right. So we're looking at all x values greater than or equal to 9, or you can write it as 9 comma infinity. And it is including the 9, so we need the equal to or the bracket. When we graph our rational function, remember the bottom here is telling me where my vertical asymptote is. So since negative 3 makes the bottom 0, we've got a vertical asymptote at negative 3. Our horizontal asymptote, because our exponents are the same, we have an x over an x. We've got a horizontal asymptote at y equals 1, because we look at the coefficients, divide those out. X-intercept, we set the top equal to 0, so we're going to say x plus 4 equals 0. So we have an x-intercept at negative 4. y-intercept, we plug in 0, so we're going to have 0 plus 4 over 0 plus 3, which would be 4/3. So this equation will come down, oops, that's the point, through there. This one's going to come up, oops, except not cross your asymptote, and go up like that. Okay, 9, we want to identify a horizontal and vertical asymptotes of our function. So when we look at this, we first need to factor the bottom. So we've got x squared over x plus 3, x minus 3. So -3 and +3 both make my denominator 0. Nothing cancels out, so those are both going to be vertical asymptotes. So vertical asymptotes will be x equals 3 and x equals -3. Horizontal asymptotes, we go back to the original. So we've got a squared over a squared. Since they're the same, we're going to use the numbers in front, which is 1 over 1. So our horizontal asymptote will be y equals 1. Here we're looking for asymptotes, and we're including point discontinuities or holes here. So this is holes. So we need to factor the bottom, x minus 10 over x minus 10, x plus 2. So if you notice, the x minus 10s cancel out. We're left with 1 over x plus 2. Because these cancel out, 10 is going to be a whole, because 10 minus 10 is 0. -2 makes this one 0. Because it's left over, it'll be a vertical asymptote. So my vertical asymptote is x equals -2. My whole, the x value is at +10. To find the y value, we're going to plug it into what's left over. So we're going to have 1 over 10 plus 2, which will be 12, so 1/12. Horizontal asymptote, again, we look at exponents. So we've got an x over an x squared. Since the bottom is bigger, we've got a horizontal asymptote at y equals 0, because the bottom is bigger. Finding the domain, here on this rational, -3 will make my denominator 0. So that means my x values can be anything but 0, because but -3. If it's -3, then we are undefined. So we're going to say x is not equal to -3. We can also say -3 to infinity, union, we can say -infinity to -3, union -3 to infinity. Either way is fine.